On this first video of curve sketching, we will be given a graph of f prime of x and asked to make a rough sketch of the function f of x. Here we have a graph of f prime, and I always recommend starting by organizing a sign chart on the bottom. And you start off by finding where f prime is equal to 0. Let's find the zeros of f prime, and that happens at the x of -1 and 3. We will need those values in our sign chart. You also want to find where f double prime is equal to 0. F double prime is the derivative of f prime. In terms of a graph, we're going to interpret that as the slope of f prime. So I'm looking for where the slope of f prime is 0, and that happens at this horizontal tangent line when the x value is 1. There's our critical x values we need. We need -1, 1, and 3. The information that provided us was that f prime was 0 when x was -1 and 3, and f double prime was 0 when x was 1. Next, let's get some more information about f prime. We know f prime gives us positive values when x is less than -1. We have a positive f prime function value, and when x was greater than 3. And then f prime gave us negative function values between -1 and 3. So I'm going to mark that by noting negative sign values, negative values for f prime of x all the way from -1 to 3. Don't worry about crossing over the x value of 1. F prime does not change its sign at that location. Next, let's look for f double prime values. F double prime, again, is the slope of f prime. It's the derivative of f prime. So I'm going to look for slope values. So let's draw some tangent lines to the curve of f prime. Here's one tangent line I'm going to mark, and then take note of what that slope looks like. And to make it a little bit easier to see, let's do another one. There's another tangent line which has a negative slope value. So the slope of f prime is negative. That means f double prime is negative. And that goes all the way up to the x value of 1. That's where we hit that horizontal tangent line. But when x is greater than 1, the slope of these tangent lines look positive. That means f double prime will be positive for all these x values greater than 1. Now let's organize again what this means. When f prime is positive, what that means for our function f is that f will be increasing. When we have f prime negative, that means our function f will be decreasing. And f double prime gives us information about whether the function f is concave up or concave down. When f double prime is negative, that means we have the function f will be concave down. I like to mark that with a concave down shape to remind me that. And when f double prime is positive, that means the function f is concave up. We're ready to start organizing this graph of f. Let's first start off by marking these key zeros, the zeros of f prime and f double prime, that is. The key x values we have are -1, 1, and 3. Let's start by looking at x values to the left of -1. Looking at our sign chart to give us direction here, we have f prime giving us positive, so we know our function has to start off increasing up to -1 and in a concave down shape. So let's mark that increasing concave down. I'm going to pause when x hits -1. I don't know what that y value is because we don't have any initial values for the function, so it is just a rough sketch. The y value does not matter right now. But what we do know is when x hits -1, the function will turn around and start decreasing, but it will stay concave down until it hits x value of 1. So there's a change in sign from f prime going from positive to negative. But f double prime stayed concave down, negative sign for f double prime. And then when x hits 1, the graph will still decrease all the way up to 3, but it decreases in a concave up fashion. And then when x hits 3, it will continue to be concave up shape, but the graph will start increasing. But then it will continue to increase. And it looks like, if you take a look at function f, it looks like it's a cubic function. And that looks reasonable because then the derivative of f prime, should look like a quadratic function.